I'm very happy to have Sarah here. Actually, present, we're kind of going back to post-COVID setting where we can actually get people to come to places, which is really cool. Mm-hmm. And really lovely to have you here in this small establishment of ours. And just to introduce a little bit what we've been working on is, so we're called the InnovationLab, very original name, but very meaningful. We're called the InnovationLab at La Plateforme, and La Plateforme is Marseille's digital, first like campus for the digital with big ambitions and kind of a lot of interesting projects, but also very freestyle approach to how people learn things about technology. And we're working on decentralized social networks at the moment. So one of the labs dedicated, it's like a 2.5-month program, which is dedicated to exploring futures of decentralized social networks and kind of, well, I guess just asking the question whether it's something that is viable in the first place, but also tackling, well, kind of trying to approach it through working with different small communities in Marseille. So we're kind of interested in the things that Sarah is working on, both as an artist and also as part of the, well, circles, I guess, and also other things that you're going to talk about today. And yeah, and she's going to also do a workshop tomorrow, which is going to be more about trust in social media and kind of collectively thinking about what that means. So without further ado, thanks to everybody from all around the world who are connected. I can see people from the US and China, and it's really cool to have all this, well, the small but kind of nice network going on. So on to you, Sarah.
Thank you. And thank you everyone for coming in person, and thank you everyone for coming online. I'm going to do my best to try to monitor both of these spaces, but I am going to turn off my webcam camera so that you can see the slides better. Actually, because I can't see the chat, can you maybe wonder if anyone stops being able to hear or whatever?
Yeah, I'm on it.
Okay, wonderful. So yeah, the talk is called Cobwebs That Connect Us, and it's all about social networks and trust. You already know my name is Sarah. I'm an artist and software developer. I've done a lot of projects in this space. Here is one that is maybe older but relevant. This is a piece where I got interested in making a kind of image with machine learning that was very different from the kinds of images you normally see made with machine learning. And so I turned a generative adversarial neural net on the images of social media interfaces. And I wrote a bot that logged in as me to 10 different social networks, fake clicked, captured screenshots, and generated a data set of 10,000 UX images. And then it generated these sort of weird, blurry, disorienting social media websites. One of the ironies of this is it also has this weird layer as an anti-surveillance gesture, because while I was writing this bot that was logging in as me and making all these fake clicks, 10,000 fake clicks, there were far, far more fake clicks than real clicks. So as a result of me creating this project, the data about me that all these companies whose platforms I was using have is far worse. This is another project which feels relevant to social networks. This is a collaborative project with an artist called Brenna Murphy. And we made this during a residency at Arbeit Gallery in London. So this is a web ring. We made a forum, people applied to be part of it, and then they joined our web ring, sort of returning to the, I don't know if you remember, like web ring projects from the 90s internet or 2000s internet. It was a way of connecting websites back when search engines were pretty bad, and social media networks were also nascent. So maybe this is like an experiment in returning to some of the things about that era, like a web that is slightly illegible to the world of big data. Because this little box that people would inject into their websites once they join the web ring is random, it's randomly placed, it links to a random place every time the page is loaded. There's a way in which this is very hard to parse for a bot like Google's that is scraping the internet and trying to map it all the time, because it's always changing. So this is maybe thinking about community outside of capture. And this is a project that I worked on for a long time. I'm still on the advisory board. And we can talk about this a lot more in the workshop tomorrow maybe, but this is a community currency that is using a trust network to distribute a universal basic income, or a currency that leads to a more equal distribution of wealth over time. And finally, this is my plug of something that is coming up. I'm the co-organizer of this conference about all aspects of the distributed web. It took place in Toronto, but has moved online since the pandemic. And we're actually going to be doing an event this year. So if you're interested in decentralized web, maybe there will be some updates coming. So what is a social network? Duh, we all know, we use them all the time, right? But the part I'm interested in specifically for this talk is the network part. What is a social network? So this is one way we might see Facebook, but this is another way to look at Facebook. So this is a diagram of someone's friend clusters. And maybe it's more true in some way, because you see an interface when you look at Facebook, but what does Facebook see when it looks at you? So that little diagram on the Facebook homepage is actually quite accurate. It's all these little people with all these connections between them. And what you get, what a diagram like this is called in the general sense, is a graph or a network. So these might be familiar to you, but just in case they're not, a graph is a data structure that shows a network. So it's made up of all these nodes, smiley faces, and edges between them. Contained within this shape is a way of structuring data. And there's a lot of complexity and a lot of possible difference in the way you might implement these networks, which we're going to talk about today. And it may seem obvious to think of social relationships as these kind of network-like connections, but it actually had to be discovered. So the idea was first introduced in 1954 from the discipline of anthropology. And this paper is from the 1970s, and it is discussing pretty extensively what is still a problem today. We build these models, but do they hold up in practice? Every computational implementation of a social network is coercing human connections into quantifiable metrics and data structures. And the question we can ask ourselves is, do these metrics accurately represent our real connections? Does the existence of these metrics or structures change the connections? And this is a legitimately difficult question. But if it is so difficult to model trust in computing, why might we do so? This is kind of like the carrot for why you might take on this project or care. These are a few areas where trust is very useful if we have a good model. One is identity, reputation systems, recommendation and curation algorithms, and content moderation. So you're probably familiar with this idea if you are building software already. We have this sort of one normal version of the internet where a client makes requests to a server in a cloud that is sort of keeping the data. But there's an alternative way of architecting the internet, which is peer-to-peer, where instead you form a network with your friends or other computers, and each computer takes its turn to serve requests and be a client. So the data is stored collaboratively across the whole network. BitTorrent is the first peer-to-peer system that had a wide user base. Bitcoin is also very well known and operating this way. Most blockchains are, and other protocols like DAT and Scuttlebutt, which we can talk more about tomorrow maybe. But you can make a similar parallel distinction in terms of architectures of trust. So you have sort of a normal version where in an identity, where you have a trusted authority. And in an identity system, that might be a government, who is the trusted authority or keeper of identity. In the case of a recommendations algorithm, maybe it's critics and prestigious publications. In the case of content moderation, you know, Facebook has its official policy. But we could also imagine peer-to-peer implementations of trust. The internet has a network stack. Maybe you've seen diagrams like this. And at the top, we have this sort of social layer of the applications we interact with. So you can talk about networks, trust, and decentralization hitting at all the different levels of this stack. So they can have different levels of decentralization and also different implementations of trust. So at the top, social trust, how we might trust one another, created and viewed through interfaces like Facebook, like social media sites. We can also have models of trust operational at the base of the network stack, where computers are trusting each other through a series of algorithmic processes. And maybe what we're saying will speak a little bit about both. So this is my summary of properties of social networks, which we are going to run through one by one, if we have time to get to them all. The first is directed versus undirected. You've seen this graph already. This is a undirected network. So each person in this network is connected both ways. The arrow has a point on each side. This is a directed network. So a model for this to think about is Facebook, where I make a friend request, but there's no connection unless you accept, and then we're friends. It goes both ways. Versus something like Instagram, where I follow you, but you don't have to follow me back. The connection is one-sided. I think it's interesting to reflect that earlier in the world of social media, big platforms like Facebook and I'm showing my age here, but MySpace, they launched with undirected trust. So it was always reciprocal. It has been somewhat more later with big platforms like Instagram and Twitter that we see a rise in directed networks. And I think it's interesting to ask, has there been a major shift from undirected to directed trust as the default mode? If so, what does it mean? What has changed about us as users of the internet and our use about these platforms? And I would argue that there's been a shift in the semantic meaning of trust on the internet from knowing people to subscribing to content, or trusting people perhaps to trusting information. So sticking with the example of Facebook, you can create a page which is different from a personal account. The page can have followers, not friends. But at this point, you have abstracted your identity from yourself to become more like a brand. You do still see undirected trust, for example, in Discord, like a Discord friend request. But usually those are places where there's no browsable content. And the context is still more like a phone contact or someone you might know in real life. A graph is a generic data structure, but it has specific properties and specific shapes. So here are two, a random graph and a small world graph. The random is exactly what it sounds like. The connections are distributed randomly. The small world one is a little more interesting. The main property that distinguishes it is that on average, the length of path between any two nodes is shorter than you would expect based on the number of nodes. So what that means is that in the small world graph, we have this pattern of highly connected nodes that lead to shorter paths between everybody. So if this was a communication network, you'd have some nodes routing more than their fair share of traffic. Or if it was a friend network, these would be the extroverts. To make it really literal or easier to visualize, a lattice graph is about the farthest thing away from a small world graph you can get. So you can imagine if I was trying to crawl from one corner of the lattice to the other corner of the lattice, I have tons of steps to make. And in the small world graph, that is not happening. I don't know if folks have seen this diagram before. It comes up a lot when we're talking about decentralized tech. But I have it here to point out that actually the middle graph most closely resembles a scale-free graph. And fun fact, actually the internet was designed to be architected like the middle version, and still is in some ways. We see this pattern of network everywhere. So this is an airline network of all the flights between different airports in the Delta flights in the US. In the airline world, it's called the hub and spoke model. And this is the map of the internet. So you may have heard of 6 degrees of separation or the Kevin Bacon number or any of these sort of games. It turns out all of that is real. And it exists on the internet too. So every website on the internet is a maximum of 19 clicks away from any other website. So small world properties are found in many real world phenomena, including website navigation menus, electric grids, networks of brain neurons, and of course, social media networks. So to return to the idea of a directed versus undirected social graph in the context of a scale-free network, I think that they are connected. So using the Facebook example again, the amount of friends that a personal account can have is capped at 5,000 by the platform. There is a human limit to the amount of people that you can know or meet personally, and it's probably much less than 5,000. So I think to some extent, the shift from undirected to directed trust enabled the scale-freeness of social networks to intensify. And maybe it's worth reflecting on how some of the woes of contemporary social media having to do with fake news, manipulation, the outsized impact that a single individual or group can have on a platform are the result of nodes which are able to be more highly connected than ever before. Okay, our next property of social networks, binary versus weighted. This is a directed graph. You've already seen it, but the connections are binary. They're either there or they're not, 1 or 0. This is a weighted graph with the weights, actually you probably can't read this, but they're expressed as percentages or darknesses of the arrows. So not only do I trust you or not trust you, I also express an intensity of that trust. Where do we see weighted trust? I think the things, the place where it is most common are rating and reputation systems. So these are a driving app where you rate the driver. And this is restaurant recommendations on Google Maps. So though we see these presented as a single number in the interface, they're actually the aggregate of many ratings given by many people, which can be thought of or mapped as a network. In a peer-to-peer context, an early version of decentralized trust network was probably the Pgp Web of Trust. PGP stands for pretty good privacy, and it was a protocol, it still is a protocol for sending encrypted messages. And it also had a weighted trust network. This is a diagram of the Web of Trust of Linux users in Philadelphia, and the shape is probably starting to look familiar to you. In PGP, what people did, and they sometimes still do, is they verify each other's identity at an in-person event called a key signing party or crypto party. They sign each other's keys, which creates a kind of directed connection between them. And over time, all those connections of people who signed each other's keys takes on this network-like shape. This is what a PGP key looks like, in case you wondered. And when you're signing someone's key, you can also give it a trust weight. And there are actually 2 layers of weighted trust in PGP, and honestly, it's complicated, and usability is one of the biggest complaints that people have made about it. But the 2 kinds of trust weight that you give are, one, I weight how thoroughly I have verified your identity, and then a second weighting for how carefully I believe that you will verify the identity of others. But I think it's really interesting that trust weights, or the markers of trust intensity, were part of decentralized trust networks right from the very start. And just briefly to return to the idea of scale-free networks, there's a subset of PGP keys called the strong set. As of the year 2015, there were about 55,000 keys in it. And this graph is the number of signatures that any given key has in that set. So the number of connections. And this is an analysis finding that it had the same distribution of connections as a scale-free network. Okay, so returning to our idea of a rating system, where you rate individual restaurants, but the interface displays a single score. How might you find or calculate a single trust score over a large decentralized network graph? And the simplest way would be to look at all the connections going to a single node and find the average, but let's talk it through a little more. a lot of people who study trust models point out that trust is transitive. So if you were taking the perspective of the central user, you would ask how much should they trust one of these users who is a little farther out and not directly connected to them. And the central user might want to weight their trust for the trust that their friends have. So I don't know if you can see these blue, lighter blue lines here showing sort of 0.75 times 0.25 as the sort of the middle person weighting the trust for a farther person out by the amount that they trust the person in between. And maybe you can imagine this a third level out, and you can imagine this graph getting bigger, and there's some maximum number where you would have gone through the whole network if you'd gone through all these hops. And I didn't draw that because it would have taken a really long time. But you can imagine that if you did it for every person in the network, well, what you would find is that the weighted trust scores for all of these people would actually converge. And because of this convergence, you don't even have to hop through the whole network, probabilistically speaking, if you have a huge, huge network. You can just make a certain number of hops and then infer a trust score from there as though you had hopped through the whole network. So shown here as a single number. Interestingly, this image is not here. It's supposed to be another network graph, as you can imagine, but one specifically from Google PageRank. The process I just described for you is a very simplified version of an algorithm called eigentrust, which was proposed to come up with trust scores for people participating in the BitTorrent network. But another way that you see this operating, or another place you see it operating under the hood, is Google PageRank. I don't know if anyone's heard of Google PageRank, but it creates a weighted trust graph with the importance of various websites based on how many other websites link to them, and it uses it to sort them when you search a particular term. So I'm sorry you can't see the graph of Google PageRank. Our third parameter for trust networks that we're going to talk about today is global versus local. So we've already seen to some extent that you can calculate a global trust score from a set of local scores. And these are all, for the most part, representing global trust scores. And we've seen this drawing of a fairly small network. Global versus local has to do with how transitive we think trust is or should be. So if I trust you, how much do I trust the people that you trust? We looked at it shown one hop out. But if the network were bigger, how much should trust extend? Or maybe we should keep the circle small and not extend it so much. You know, maybe it only goes so far. Let's talk about some of the affordances of global versus local trust. So both of these clusters are strongly connected to each other, and they both trust each other really highly, which is fine. Maybe these are two friend groups. But what if it's Twitter, and we introduce someone into the friend network who is highly polarizing, like Donald Trump? I don't know if you can see that. That's Donald Trump in the middle. One cluster trusts him a lot. I should have put a picture of him. Anyway, one cluster. Yeah, when I do this again, we'll add more memes. And one trusts him only a little. But if we calculate a global trust score for this kind of person, we might get a number that's totally in the middle. But is this useful? Maybe. But it's not useful in terms of recommending what kinds of posts these two groups of people want to see. And it's also not useful in terms of representing what's really going on in this data. A more local score might give us a better answer. So if we look at the cluster of people who all trust each other very highly, but really don't trust Donald Trump, and we calculate a trust score based on them only, we'll get a very low number. And then if we did the same thing for the other side, we'll get a much higher number. And Donald Trump is an easy example. And maybe when you think about it, you have a very strong feeling about whether people should see his posts. But this effect could apply to anything that is sufficiently polarizing or niche or subcultural. And so I would suggest this as a heuristic. Too much globality in trust scores can flatten difference. and too much locality can polarize. Finally, we've talked a lot about trust, but trust has different meanings. And we already saw this slide. What we mean by trust is somewhat different at different layers of the network stack. A paradigm that is common at the network layer of trust, and makes sense also for some social definitions of trust, but maybe not others, is a Sybil attack. So a Sybil attack in the context of the network layer would be when I create a bot that makes many, many fake computers, and I have as many nodes on the network under my control as legitimate nodes. Something that is often used to deal with this in a peer-to-peer context is a seed set, or a starter set of peers who are trusted by, known publicly. And this is used in both PGP and in eigentrust. Looking again at these two clusters of friends from before, what that means is that if one side was our seed set, even if we had a malicious ring of people working together to make a bunch of fake accounts to all upvote each other's content and give each other high trust ratings, they would be detectable. Because no matter how many trust connections come in from this malicious side, you'll see there are none here, or perhaps very few coming out with the known trusted set of peers. But if a trusted real person joins, the thinking is that they can easily get themselves trusted by other real people. And so it doesn't matter how many of the malicious nodes are created or how many bots are getting added to the network, because again, if there's no more connections coming out from the known set of people, it's still easy to detect the edges of the malicious ring. So Sybil attacks come up a lot in a peer-to-peer context. They come up in blockchain mining. They can come up in certain types of social trust that has to do with identity. And so it's always important to think about that we can't use just the simple quantity of nodes as a guarantee that they're real. But this is also related to globality and locality of trust. And the way it relates to that is the semantic meaning of trust. So at the network layer, this is probably what you mean when you say a node is trusted. Eigentrust was designed in the context of the BitTorrent network. So a trusted peer sends me the correct files. An untrusted peer sends me a virus. In the context of a blockchain network, it would mean they make a correct block on the network, or they steal money. And so it makes sense to call these nodes Sybils or attackers. There's a fairly objective definition of bad behavior. But in the social context, trust could mean all kinds of things. I trust you to recommend music. I trust you to help me make political decisions. Or maybe something somewhere in between, something as subjective as what type of music you like, and as objective as did you send me a computer virus, is do I trust you to drive me home safely? So there's a representation of trust in most social platforms, but the semantics are not always equivalent depending on what your semantic meaning is, what you mean when you say trust. And design choices should flow outward from here. So I've already said this, but I'm summarizing that the concept of a Sybil attack only makes sense if your idea of what trust is can be applied globally. So just to reiterate, we're coming to a close. These are the properties of social networks that we talked about. We talked about whether they're directed or undirected, which way the connections go, or both, whether they're binary versus weighted. Is there any way to express an intensity of trust? Do we look at them from a global or local perspective? And finally, what do we mean when we say trust, if we were to expand on that concept with a full statement? And finally, talking about use cases, we'll get into the use cases more if you're coming to the workshop tomorrow, but different use cases need differently shaped networks. So for example, I would suggest that identity lends itself more perhaps to a global model of trust, and it is perhaps more Sybil attackable as a system than a recommendation algorithm. Thanks.
any questions? Because I have a question online, coming from online.
Mhm.
Could it be said that networks impose weights to my trust in others, people I follow or I'm connected with, by curating my feed, basically? So whether if did you get the question?
I see the question. I'm back.
Ah, great.
I'm back
Cool.
in the reading
maybe
chat
you can
also
just read
mode.
them out or something.
Yeah, Leon, I would say that absolutely something like that is going on. For example, if we're looking at Twitter, I don't know the specifics of how Twitter is curating your feed, but I suspect it is tracking how long you're looking at things, whether you're clicking on them, and under the surface, adding weights to whether you follow people or not, and also probably subjects as well. So yeah, just because you don't see those aspects of the network doesn't mean they're not operating under the surface with the platforms. A comment, which I'll read. Based on interviews, Crystal Abedin writes in her article, Communicative Intimacy, that in relations between influencers and followers, the more a follower would like to be friends with the influencer, the more they are likely to trust what that influencer recommends. That is super interesting and feels right to me. And if you have a link, maybe you could post it in the chat for others.
That would be great. I was thinking, yeah, how do you like? Is there like a hybrid? So, well, because you talk at the very end, especially about distributing trust on like different layers for different things. So let's say identity. So how complicated does it get with different kinds of attributions, even if you keep it? So let's say we keep the network very small, right? Is it like, I'm talking both kind of from a conceptual perspective, but also from the technical one. I imagine that you have a small network, but you have different kind of ways of attributing trust to different kind of things. So it's like, how do you kind of, one thing like is how do you actually deal with this complexity, and then also how do you explain it to people who use it, right? Because I know people here might not be experts in network theory.
Nor am I. So I guess this is the space where I'm like, you should draw that network, then we can talk about it. But to take the last part, how do you deal with the complexity of getting the user to understand all of this? That is a very big problem, and I don't think there's one good answer. The example I talked about the most is Pgp, which is like famously bad at this. At Circles, which I worked on for a long time, we simplified what was possible on the network level to the user a lot. I think that's also coming in when you see sort of like an app gives you a global trust score for a driver, but it doesn't tell you anything about how it's calculated that. That's a form of presenting the data for the user as well. But I think that maybe the thing to do would be to look at the specifics of the system and which parts are most important, and then user test. But I think there was another part of your question which had to do with expressing different types of trust within the same application, you know? And well, I think that's kind of also a user interface question. Like, do you call them all trust? Do you see different categories? You know, maybe we can talk about it tomorrow and like draw some shapes for what that could look like.
That's quite interesting. Yeah, because all this like this kind of question is emerging from my side, because all of the kind of little networks that the participants that can speak for themselves also are imagining at the moment are kind of almost all of the networks are critically engaging with trust. Because also they're very local, so you're dealing with something that is very, very kind of, you almost know the people you're dealing with, and yet there's suddenly digital interface. So let's say you're talking about an autonomous organization of people, right? But we're also working on geographically specific communities, which are all in Marseille. So you kind of provide them with tools to organize themselves digitally. And at the same time, yeah, that's why I'm kind of interested in this fact of that there is this kind of social, presence. If everybody knows each other, then there's some people you don't know, so you get them on board at some point. And then so how do you kind of, how does it go back and forth between the physical space of me talking to you right now and then me looking at you in the camera, right, at the moment as well? So imagining that it's not only to do a webcast, but it's to share services, to put money in common, and all that. So it's not really like a question, it's more like a hypothetical kind of reflection on it, right? That I'm just understanding that we're working with people who are not necessarily part of, software developers. They just came here because they want to think about social networks socially. And then as soon as you enter that complexity, right, how do you kind of juggle between the two?
Well, I mean, it's different to be a user and a designer of a social network. Definitely, you think about it differently. And the way that we've talked about it today is quite abstract. And I think that there's like a utility to looking at it in a general sense, because you can sort of observe patterns across networks and across implementations. But I think that, each particular implementation has specific questions, like what do you present to a user? What do you show? And maybe some of the things you talked about also relate. I'm thinking about like, there's a local context, but then as people are joining, how does that network scale or grow out of its local context maybe? And so I think that, I think that there has to be a iterative cycle between this type of abstract thinking that this talk was about and on the ground talk with actual people who are using the work. Yeah. I saw, a couple. Do you want to?
Yeah, sure. Thank you for the presentation. According to me, I think your understanding, your vision of social networks are really based on graph theory. Yeah, sure. And I want to ask a question about weighing. You just said that it depends if you evaluate or weighted. And about trust. For example, let's see in the social network, I think the experience that I can't have an experience with just a bad experience. I don't really appreciate some kind of thing that he did, and our collaboration go wrong. And because of that, I can just leave a bad comment or rate him badly, and it's not that just not mean that I'm a bad person, right? And at the same time, I can also have an experience with and this experience would be really interesting. How could we balance? This kind of in the within social network.
No, I'm just thinking whether, I don't know if people heard the question, but so if you could just like summarize to the people online, I don't know if they heard it because it was far away from the microphone, or you can just answer.
I can try to answer or summarize. I will try to summarize for the people online. The question had to do with sort of something very subjective, like having a personal experience with someone that didn't go so well, but it's not reflective of them as a whole. It's just sort of one interaction, and how you take that into account when you're designing networks. And I would say that that is about a question about the last 2 points, really, and how they're related. So something that is very subjective is something where, like you wouldn't, thinking globally about the whole network doesn't necessarily make sense and isn't so applicable. And also, in this case, if you gave a bad rating to somebody, and I wanted to know how seriously I should take that rating, I might want to look at how much I trust you, so it also has to do with locality. I would say that kind of very subjective context for trust probably is not best passed too far out. And so my examples for that were around like music, because this feels very completely subjective, actually. And I would say it's probably more helpful then, a maybe more loaded context where you deal with similar questions is content moderation. So like, how do I know if a post counts as harassment or not? People have different thresholds for this and different types of things they want to engage with. And all of these benefit, I think, from not being too transitive. Or perhaps even we design a network where, if you're too far away from me, I can't even see the ratings that you've given, they're like invisible. I can only see the people in my locality, for example. And I think that captures subjectivity more. Is that?
All right, so if you understand, does that mean that more than the rating, there's another rating system based on the distant localities and geography and things like that, right?
Mm-hmm.
All right, so if, for example, I'm working on a social network really focused on, for a kind of professional, right, for physicians or for people which are more related about the kind of topics or the kind of by the job, in this case, will this kind of signal level rating be also applied or not, according to you? Sure.
Well, if you're working on it, it should be according to you. But I think that, for example, if you were implementing a rating system there are websites where you rate doctors that I've used, and they may be very different than the ones you've used. But you could take into account the user, does the person making the ratings have a history of making angry ratings, for example? You could also look at your past ratings and then that person who made the angry ratings, past ratings, and look at how much they match, maybe. And if you have historically agreed with that person, you could weight them more strongly in terms of what it shows you as an option. I think there's a lot of options, actually, but this is the kind of thinking that I think it's useful to do. Yeah. Yeah, if you're coming tomorrow, we can talk about use cases a little more.
It's okay, we have quite a lot. There's also a couple of very good questions online. Maybe let's go back to online and then keep one question each, and then, yeah.
And maybe I'll answer the online one so that the online people can get out of here.
That's okay, it's okay. There's only two online. One is that, do you think in the Pgp Web of Trust, trust can be considered as an emergent property? Yes. Yeah, I think the entire shape of that network is emergent. And I think that if we were to run any type of trust calculation across that network, we would find emerging values around reputation there. So you could run something like Eigentrust on Pgp to get an emergent trust score for each person in that network. And another question from online, can you talk a little bit about trustless networks and the role of game theory in setting parameters and how people's subjective behavior follows or diverges from the game theoretic prediction? Yeah, this is like my pet question. This is what so much of what I do is about. And if you're coming to the workshop today, we're going to totally play game theory games, which are not fun because I love them, if there's time. But yeah, so a lot of people use the word trustless when we're talking about peer-to-peer networks, like a blockchain.
It is my belief that those networks are not trustless, actually, and that there's all kinds of trust operational there. For example, to name some of the types of trust operational in the Bitcoin network, trust in the correctness of the protocol, trust that the cryptography is not broken, trust that if the cryptography was broken, we would know about it, trust that the developers correctly implemented the protocol spec. So there's actually a lot of trust going on. And there's also a trust in, like you said, a kind of incentive. Now, I think that, so I think the word trustless is a misnomer. That's the first point. But the second one is the way that game theory gets talked about in these networks. And that is that there is this idea that if we correctly design incentives, we don't need to trust one another because the incentives will work on their own. And this is operating from a kind of way of seeing the participants in the network as rational and self-interested. And I think that that's, there's a very good question underlying that, which is it true? Is that what the people participating in the network are? And this is the part where we find interesting things that diverge from the game theoretic prediction happening more often than you might expect. And one of them is an example from the Bitcoin network itself, actually. There's this thing called a 51% attack, which is when one person takes over 51% of the network. That's called a Sybil attack. We talked about those. And you might imagine that if someone was able to do that, they would, you know, like they would take over the Bitcoin network and get all the Bitcoin and sell it for like lots of money, you know, because they could do that if they had more than half. But actually, it's happened that someone does have more than half of the hash rate on the Bitcoin network. But what has happened is that they have not taken over. They have not stolen money. What they've actually done is voluntarily scale back their operations. And I think that that's an example of the assumed selfishness of the miner not existing quite to the extent that some people might think it is. Another way to think about that is the Bitcoin network is actually an iterated prisoner's dilemma, not a one-off prisoner's dilemma game. Okay, we've probably gone too deep because I really, really love this subject. And there's people in the room who have questions too, and maybe don't care about game theory. So yeah, sorry.
Yes, in a world where everyone gets a note based on their relationship with others, what metrics do you use to say that I can give a note on somebody? Like how much interaction do I need to have with somebody to be able to give him a note, and how much people should I note to be able to give a note to be able to know how the people will rate others.
Mm-hmm, mm-hmm. So you're asking how sort of how far out can the note pass?
No, like in a world we will have an interaction. Then after I give a note. What number of interaction do I need to have with somebody to be able to give the note?
I see. So you're asking, before you might give somebody a rating,
Mm-hmm.
how much experience should you have had with that note to give it a rating? I think that depends on what that rating means in the context of your app. So often, I think we see implementations where it's not really verified, actually. So Google, where I'm rating a restaurant, I can just make that, You know, it doesn't. I don't have to like prove that I ate at that restaurant,
Yeah.
right? You could imagine a system where I did, but it's not implemented that way. You do prove it in the context of a driver rating app, where I don't believe you ever see the rated driver screen unless you took a ride with that person and it's used your location the whole way. But I think it's a very interesting question, and maybe depends on your app, you know? If it's about, you know, if that's not a one-off interaction and it's about a content moderation question, for example, you might not want to rate somebody unless you know them quite well. And maybe depending on your app, you could enforce certain amounts of interaction to have happened before rating. You might introduce a somewhat kinder system by doing that. But I think that it has to do with really like what trust means in your specific context.
And is it better to have a set of interaction, a fixed number, or a changing number?
Again, it depends, I think, on the specifics of the app. If you expect that you might interact with someone again and again, it makes sense to be able to update that with new information. Another way you could deal with this is you could weight the importance of the weighting by how much interaction the two nodes had. So, for example, if I just met you and the app knew that somehow, and I gave you a rating, the app could say, we're just not going to count this one, you know, because we could count it, but only a little. And then as we continued to interact, you know, if I adapted that rating or had a pattern, then that rating itself could become more important. These are all sort of design choices. And I think that, you know, why I think this is interesting is all of these things are going on at these big platforms. We just don't have any insight into how they've been implemented. It's not transparent to us. I long to be able to open something like Twitter and then see how what I see would change if all of these things were different in the app, you know? And so I don't have a right answer, unfortunately. But if you're curious, maybe like there's a way to experiment with the differences.
On this note, we can continue. Maybe like there were some more questions, but I would just like to maybe close the session because we're passing 1 hour.
Thank you for coming and listening, everyone.
Oui, on peut poser toujours la question, mais on a fermé la session en ligne. Oui, mais c'est bon. En fait, je vais juste fermer la session en ligne. So, just wanted to say to those who came online, thank you very much for coming. This is our second intermediary talk. If we have some more, we will, of course, let you know. In the beginning, I was very stressed out because we had a presentation today. So we're quite tired, but I just wanted to thank our partners, which is Frankfurt and the Finnish labs. And so thank you first of all for being here, and we'll keep you posted on the progress we have, and very soon we have some projects coming out. And again, thank you, Sarah, for a lovely talk on all these issues that are kind of never ending.
Truly.
Yes.
Truly. The more you pay attention, it doesn't get any easier. The answers don't get any more obvious.
We can wait.
Thanks, everyone.